I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this video, we have taken some questions based on double angle. You may take this as an assignment. We have 4 questions to discuss. Question number 1 is solve the equation 3 cos 2x minus cos x plus 1 equals to 0, where x is between 0 to 2 pi, both included. Question number 2. Use the identity cos A plus B equals to cos A cos B minus sin A sin B to show that cos 2x is 2 cos square x minus 1. Based on this, question 2b, hence solve the equation cos 2x minus 3 cos x minus 1 equals to 0, where x is between 0 to 2 pi. Question number 3. Show that the equation sin 2x minus tan x equals to tan x cos 2x is an identity. Question number 4. Solve the equation 3 sin 2x cos x equals to 2 cos cube x equals to when x is between 0 to 2 pi. Boundaries not included. So these are the 4 questions for you. I would like you to pause the video, try these questions out, and then look into my suggestions. In case you want to learn from me, you can always send an email on the address given here. Now let's look into the solution of these questions. Now before that, let's check the formulae. I hope you remember the compound angle formulae, which are sin A plus B is sin A cos B plus cos A sin B. Sin A minus B is sin A cos B minus cos A sin B. And for cosine A plus B and A minus B, we have cos A cos B minus sin A sin B, or with negative sign, here it becomes positive. Note a change. When we have cos A plus B, we have a negative sign here, and for minus, we have a positive sign. The double angle formulae are with sin 2x you have 1, which is 2 sin x cos x, and with cos 2x we have 3 equivalent formulas. You could write this as cos square x minus sin square x, or 2 cos square x minus 1, or 1 minus 2 sin square x. Well, in one of our questions, we will be deriving this particular formula also. Here are some related formulae which could be of use to you. Have a good look at it. Now let's begin solving our questions. The idea is that when you are working on trigonometric equations and identities, you need to remember your formulae or have that list ready. Now let's look into the solution of these questions one by one. Question number 1 here is solve the equation 3 cos 2x minus cos x plus 1 equals to 0. And remember, the domain given to us is from 0 to 2 pi, so one full cycle. Now what we could do is we could write cos 2x using the formula as 2 cos square x minus 1, correct? And then we'll have a quadratic equation. So we can write this as 3 times 2 cos square x minus 1 minus cos x plus 1 equals to 0. Let's open the bracket and simplify. 6 cos square x minus 3 minus cos x plus 1 equals to 0. So now that becomes a quadratic equation. Let me rewrite this in order. 6 cos square x minus cos x minus 3 plus 1 is minus 2 equals to 0. Now we need to factor this, right? We are looking for product of two numbers p and q, which should be minus 2 times 6, that is minus 12. And their sum should be what? Sum of these two numbers should be minus 1. And that means I could write this as minus 4 and 3. So let's write this. So 6 cos square x minus 4 cos x plus 3 cos x minus 2 equals to 0. From these two terms, we can factor 2 cos x. And what we get here is 3 cos x oh, 4 plus 3. Sorry. 4 plus 3 cos x minus 2. So from here, we get 3 cos x minus 2. And here we already have 3 cos x minus 2 equals to 0. So basically, we wrote minus cos x as minus 4 cos x and 3 plus 3 cos x. That gives us minus cos x. So you group factor them, correct? So now we have the factored form of the equation, which is 3 cos x minus 2 is common times 2 cos x plus 1 equals to 0. Now from here, we can simplify each factor, rather equate them to 0 and then find the solution. So we get two factors, we'll equate them to 0 one by one and then find our solution. So the first one, which gives us 3 cos x minus 2 equals to 0, means cos x equals to 2 over 3, correct? So cos x is 2 over 3. We have to find the answer in radians. We know cos x is going to be positive in the quadrants 1 and 4, right? Using the cast rule. So we have solution in these two quadrants. Let's find the acute angle. So converting your calculator to the radian mode, then find cos inverse of 2 over 3. So we do shift cos inverse 2 divided by 3 bracket close equals 2. We get 0.841. So this acute angle is 0. Let me write this as 84 to two decimal places. So the answer will be, that is one of our angles. The other one is 2 pi minus 0.84, right? So here we get x equals to cos inverse 2 over 3, which is 0.84. So the other answer, because we are looking into this particular domain, will be pi minus this. The other value will be 2 pi minus 0.84. So 2 times pi minus 0.84 will give us 5.44 radians. So these are the two answers which we get from the first factor. The other factor is 2 cos x plus 1 equals to 0. So we have cos x equals to minus half. Now cos is minus half in quadrant 2 and 4. So this time we have our solution in quadrant 2 and 4, since we're looking for minus half. So we can find the related acute angle alpha in quadrant 1. So for half, we can also use the special triangle, which is pi by 3, right? So for pi by 3, we know the cos value is half. So we do get alpha equals to pi by 3. So the x value is going to be what? Well, these are the two x values, correct? So one of them is 2 pi by 3, the other one is 5 pi by 3, right? So we get 2 pi by 3 and 5 pi by 3. So within the given interval, we now have four answers. We can write down our answers as x equals to 0.84, 5.44, 2 pi by 3, and 5 pi by 3. So that is how we can actually solve question number 1. So basically, writing cos 2x as 2 cos square x minus 1 and factoring the quadratic equation helps us to find the solution. Correct? So I hope this is absolutely clear. Now let's look into question number 2. Use the identity cos a plus b equals to cos a cos b minus sin a sin b to show that cos 2x equals to 2 cos square x minus 1. We used this formula just now, right? But let's use this identity to show that cos 2x is that. So we are given cos a plus b as equal to cos a cos b minus sin a sin b. Now if I substitute a equals to b and both equal to x, then what do I get? I get cos of x plus x equals to cos x minus sin x, correct? So that is cos 2x equals to cos square x minus sin square x. So we got the left hand side. Now for the right hand side, we can write sin square x as 1 minus cos square x, right? So we know cos square x plus sin square x equals to 1, or sin square x is 1 minus cos square x. So we can substitute it here. In that case, we get cos 2x as equal to cos square x minus 1 minus cos square x. Open the bracket. So we get cos square x minus 1 plus cos square x. And that gives you the result 2 cos square x minus 1. On the left side, we do have cos 2x. Is that clear to you? So that is how you can derive this particular formula. So as you can see, the double angle formula for cosine can be written in three different ways. Now let's take the next example, which is based on this particular application, which we used in question 1 also. The question here is, hence solve the equation cos 2x minus 3 cos x minus 1 equals to 0 when x is between 0 to 2 pi. So it is very similar to our first question. The only thing is, for cos 2x, as we did last time, we'll write 2 cos square x minus 1. So I will write this equation and then leave it for you to solve. So we have cos 2x minus 3 cos x minus 1 equals to 0. And for cos 2x, we are writing 2 cos square x minus 1 minus 3 cos x minus 1 equals to 0. That gives you 2 cos square x minus 3 cos x minus 2 equals to 0. And I'd like you to solve this question, right? So you can factor and then simplify and find the solution. You're looking for two numbers whose product is minus 4 and sum is minus 3. So very similar to previous question. You could write this as 2 cos square x and minus 3 could be written as what? Well, 4 with a negative sign plus cos x, correct? Minus 2 equals to 0. And now you can factor and solve. Correct? So that is how you have to approach this question, which is very similar to our previous example. Now let's get to question number 3, which is sin 2x minus tan x equals to tan x cos 2x is an identity. Now, identity really means that both sides are absolutely equal in their domain, right? So we have sin 2x minus tan x. We need to prove this left side is equal to the right hand side, which is tan x cos 2x. So to prove an identity, we can begin from one side. So let's begin from left hand side. And the left hand side given to us is sin 2x minus tan x. Sin 2x can be written as 2 sin x cos x, and tan x can be written as sin x over cos x. Now taking a common denominator, which is cosine x, we get 2 sin x cos square x minus sin x. Now here we have sin x as a common factor, so we can actually take the sin x common, and within the bracket we get 2 cos square x minus 1 divided by cos x, correct? So as we just have shown the identity, we know this term 2 cos square x minus 1 is actually cos 2x, correct? And sin x over cos x is tan x. So we could write this as equal to tan x, and this is cos 2x, and that is the right hand side. So that is how we can actually prove the identity. Clear, right? Now let's have the next question, which is solve the equation 3 sin 2x sin x equals to 2 cos cube x, where x is between 0 to 2 pi. So this time the equation is 3 sin 2x equals times sin x equals to 2 cos cube x. We can bring all the terms to one side and then solve. So writing sin 2x as 2 sin x cos x, and then we have sin x here minus 2 cos cube x equals to 0. So we have 6 sin square x cos x. We can take cos x common, right? Factor it. So we get, or let me step 2 is 6. We can multiply this. We have sin square x cos x minus 2 cos cube x equals to 0. So now I have cos x as a common factor with 2, right? So we get 2 cos x as common, and this we can write as 3 sin square x, and here we get minus cos square x equals to 0. So we have a solution for cos x equals to 0, that is one factor. We need to simplify this to get the other factor, correct? So here we can write sin square x as 1 minus cos square x, and then we'll simplify the other factor. So we get 2 cos x, 3 1 minus cos square x minus cos square x equals to 0. We have 2 cos x. So we have 3 minus 3 cos square x minus cos square x equals to 0. So we have 2 cos x, and here 3 minus 4 cos square x equals to 0. So that means we can now equate these and find our solution. So one set of solution we'll get by equating 2 cos x equals to 0, and the other by equating 3 minus 4 cos square x equals to 0. Is that clear to you? So at this stage, you can pause the video and answer it further. Within the interval given to us, which is between 0 to 2 pi, I have 2 cos x equals to 0. That gives me what? It is 0, as we know the cosine function is 0 for pi by 2 and 3 pi by 2, right? So that is the cosine function, which is 0 for pi by 2 and 3 pi by 2. So that gives us x equals to pi by 2 and 3 pi by 2, correct? Now the other solution we will get from the second equation, which is 3 minus 4 cos square x equals to 0. So that gives us cos square x equals to 3 over 4, and that is that cos x is plus minus square root of 3 over 4. Now, this we have 4 solutions here now. So we have cos x equals to plus minus square root of 3 over 2, right? So this means that we have 4 solutions. We can use a special triangle. So wherever possible, use special triangles. Square root 3 and 2. So the angle for cosine will be pi by 6, correct? So we have the related acute angle pi by 6. And therefore, the x value is what? Is pi by 6. One answer, right? That's the acute angle. And then we have 2 pi by 5 pi by 6, 7 pi by 6, and 11 pi by 6. Clear? So those are the other solutions. So we can now write all the solutions. So our answers are what? We get pi by 2, 3 pi by 2 earlier. And now we have pi by 6, 5 pi by 6, 7 pi by 6, and 11 pi by 6, correct? So that is how we are going to solve this particular question. So I hope these steps are absolutely clear. You may review these formulas and then again try to solve these questions on your own. That will really help. So I hope all the concepts related to double angle are absolutely clear. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.